Okay, I'm gonna do a quick video walkthrough of my application for the design pattern project. Just because I did not do this project in Java, I wrote it in the Visual Basic language as a Windows form application. That's what I'm most familiar with. So without further ado, this is just before we get into the code. This is a quick look at what the interface is going to be that the user will interact with. As you can see, we have a spot to put the item, the price, the tax paid, and a drop down which the user can then select which country they had went to. So you'll also notice here we have checkboxes which the user can click and unclick to denote whether or not they want that item included in their final calculations. So we will also have a calculate tax button, an add item, which will allow the user to add more items. And if they keep going, you'll get a a scroll bar, and then they can always clear to go back to the original state of the form. So let's go ahead and look at the code. The strategy design pattern was implemented here, being that we have different definitions for a calculate tax subroutine depending on which country the person was traveling to. So as part of our interface class, we're going to deal with the load event firing off of the application opening up, which you can see here I have a sub that goes ahead and starts the user off with 3 new rows that they can add things to. We also have, if they click the clear button, then I go ahead and clear any items that were existing on the screen and start fresh with 3 new rows. And then if they click the add button, then I go ahead and I will add a new row that allows the user to type into. Then there's the calculate tax button, which will instantiate. We have 3 different objects here. As we'll see later, we have the class for Iceland, Syria, and Germany. So depending on further down which country the user was trying to calculate the tax for, it will call the appropriate instance of that class. And then we also have the subroutine that goes ahead and adds the new item row. And last, we have this subroutine here in the interface that simulates pulling information from a database to let us know which countries in fact this application handles. I just go ahead and return them back, but in theory this would simulate going out and retrieving information from the database. So what we do is then we move into class tax, class calc tax, and this class is actually going to have 3 variables: the cumulative tax paid, the cumulative price paid, and the cumulative tax owed, which you can see here, these 3 variables. And those are going to be set as properties that the user can then click on, or not click on, they can retrieve and set the values. And then we have an must override sub calculate tax owed. This is a must override sub because we then will have class tax Iceland, Syria, and Germany, which is all going to inherit from class calc tax. And in Visual Basic, by designating this sub as must overrides, the definition for that subroutine will then be written out in class tax Iceland, Syria, and Germany. And then in theory, if each one of these classes had significant more calculations to be done, it would all be encapsulated within each of these classes. So if Iceland had 8 different things you needed to do, Syria had 5 different things, and Germany had 17, then they would all be contained to their own class. You don't have to go through different select if statements and trace things along. Everything is contained to its own class. So you can see in class tax Iceland, we have where when the user goes ahead and passes in the 3 necessary variables which were defined in class calc tax, the user needs to enter the item, the price, and the tax paid. And they're all their correct variables. The item will be a string, and then we have 2 decimal values coming in the form of the price and the tax paid. So Iceland was defined as the users pay their sales tax up front, but when they leave the country they get refunded. So this MyBase operator here will refer back to the class, the parent class of the Iceland class. So I can go ahead and get at the property that was created over here. If we go back up here, the 3 variables were made properties. So Iceland, I'm going to go ahead and take the current cumulative tax paid variable and add to it whatever tax paid was passed in. And now if you notice, these were all set to 0 to start with. So we're going to go ahead and do 0 plus 4, then 0 plus 3, and however many times this function is called, it will continuously add to the cumulative tax paid. And then after it does that, it will update the current outstanding tax owed. And this is really simply done by taking whatever the current total tax paid is and multiplying it by -1. Because if you've paid $10 in tax, you want your end result to be -10, being that a negative tax is a refund, so that will be the money you get back. So then if we move on to Syria, their tax rate, which I define up here, is currently 5%. So then if we keep track of the cumulative price paid, because here you don't pay sales tax up front, you have to keep track of your price paid and then pay the 5% before you leave the country. So here we'll take the cumulative price paid and continue to add to it whatever the price was that was passed in for the individual item. And then we're going to go ahead and update the outstanding tax owed property. And we'll do this by taking the current cumulative price paid and multiplying it by whatever the tax rate is. And we save the tax rate up here in a variable in case for some reason that ever changes. It's saved up here and it can be taken care of once instead of moving throughout the class. So then if we look at Germany, we are going to calculate this based off a cutoff that Germany has decided will be $50, which is visible here. And the way this works is if you pay more than the $50, you're going to get refunded the money. So what we need to do is, as before, we're going to keep track of the cumulative tax paid as we did in Iceland, but this time we're going to compare it each time we run through to see if the cumulative tax paid is higher than this cutoff number. And if it is, then we're going to go ahead and calculate the tax owed, but in theory it's going to always come back as a refund in Germany since you pay it up front. So we're going to take the cumulative tax paid minus the cutoff, and then we need to multiply it by -1 so that it comes back as a refund. So what we can do now is go ahead and run through the code, and you can do this by running the executable that's attached to the project, or if you have Visual Studio 2012, you can open up the project and run code. I'm going to go ahead and run code, and then you can see here we have our interface, and I can type in that I bought a shirt for $29 and I paid $3.50 in tax. Then I bought some pants, they cost me $35 and I paid $4.20 in tax. Now I don't want to add any more items, so I'm going to uncheck this box here. And then let's say this happened in Iceland. So calculate the tax, and you can see if you add both of those up, $7.70 is the tax I get back. Now notice if you include this and you don't type anything, you're going to get an error message telling you must enter an item. And then also if you try to type a price that was, let me put in hat, and if you try to type a price that's like 20, if you try to type it or something and it's not an actual number, it's going to let you know that the price has to be a numeric value. So let's go ahead and turn that back off so you can see it functions. We'll change Iceland to Syria. Well, here you actually should pay 0 tax, and what's going to happen is that you should get 5% of this total coming back as your taxable amount. So Syria, this is you're going to owe $1.75. Iceland, you're getting back $3.50 now, and nothing's been put in for Germany. So we'll go ahead and put Germany back in. Say we paid $30 for this, and if we calculate tax, well, you're not getting any. Germany's still zero because you haven't broken the $50 barrier. So just in theory, say we paid $70, you should get back 20, and we do. Notice that I'm using parens to show a negative value for money instead of a minus sign. And then we can always add more items here, so we can add a few more and say we bought a necklace that was $100, and we paid, I don't know, let's say $14 tax, and that was in Iceland. And then we bought a brace, let's say a brace. We hurt ourselves, so we had to buy a knee brace, and that cost us $20, and that happened while we were in Syria. So we didn't pay any tax on it at the time. Hit calculate, and notice that what happens is you can mix and match these different countries here, and the application will go through, loop through, and calculate everything it needs to, and then give you your output in this message box. So it should be pretty straightforward. Anytime you want to take something off, you can uncheck, or you can always click the clear button and it'll start you back over. So the last thing to take a look at then is going to be how the strategy pattern was actually implemented. So if we go back to the code, and stop this, and we go back to the interface that's actually calling class calc tax and the appropriate encapsulated functions in the different countries, I have a loop here, and I'm going to go ahead. Now the way I wrote this was that the controls are all dynamic. They're created as the user wants them. So I have to do a loop that goes through, and I see, okay, well, this is looking at the checkbox to see that I want it included. I look at the item and do validation. I look at the price and the tax, and I'm saving things off into variables that I have defined so that I can come back and use them later. And then once I finally, through my loop, I'm going to hit the point where I see the country the user selected. So this is the only place in the code that I have to run through a select case statement to see which function I want to call, and I go ahead and I can interrogate the drop-down list and see if it was a Germany, Iceland, or Syria. I'm just going to go ahead and call the correct instantiated object of calculating that tax. So if it was Germany, I'm just going to off the object Germany, which instantiated class Germany. I'll go ahead and call calculate tax owed, pass in my different items. Then if it was Iceland, I'll do the same thing, call in the same exact function and everything. The only thing that changes is which instantiated class I'm going with. So with that said, that's how my application works, and thanks for watching.